Yesterday, we talked about how we could use one of our special multiplying patterns from the last chapter and reverse it and use it as a shortcut for factoring trinomials. Today, we're going to do something similar, but with a different special pattern from the last chapter. So we're going to review what that pattern is and then talk about how we can use that as a factoring shortcut. So the pattern was if you have a binomial that's being squared. So a plus b squared, which is really, if you expand that out, a plus b times a plus b. So we can FOIL that out to see what happens. So if we FOIL it, first is a squared. Outer is a times b, or ab. Inner is ab again. And last is b squared. So since these are like terms, we can combine them together. And your line is up over here. My formatting's a little bit differently, but you can write this on your line. So simplified, we get a squared plus 2ab plus b squared. We can do something similar with subtracting. The subtracting pattern works very similarly. The only difference is that when you do the outer and the inner, you get negative AB and negative AB again. So when you put it together, you end up with a squared minus 2AB, because those two middle terms end up being negative when you're subtracting, plus b squared. So if we look at what's happening, if we want to use this as a factoring shortcut, we have to look at how do we get from the answer back to the factored form for both of these. So answer back to factored form. So if you look at the answer, or the trinomial, we can see some connections to the factored form. So the a and the b are just whatever the square roots of these two numbers are that are sitting here. So if both of those, that first term and that last term, are perfect squares, we can just square root that or figure out what we multiplied by itself. And that's the a and the b for our factored answer. And then it's just that plus that squared. Now that only works though if the middle term is also following the pattern. So the middle term is 2ab. So basically the middle term is saying, okay, you have to take whatever the square root of this is and whatever the square root of this is and multiply them together and then double it. So we're actually going to test that out and see in just a minute how that works. So how would I check to see if I can use that shortcut? So if you're noticing this pattern, then you can shortcut from the answer straight to the factored form without having to go through our other factoring steps. So that's why we call it a shortcut. You just have to recognize the pattern and know, okay, this is the pattern. This is the answer that matches with that pattern. So how do you do that? What do you look for? So if I've got it, because these are trinomials still, so you have to be able to tell, these are called perfect square trinomials because of these perfect squares that are sitting here in the first and the last term. So they're called perfect square trinomials. So how do I recognize a perfect square trinomial where I could use the shortcut from just a regular old trinomial where I have to use the other things we've been learning about in this chapter? So this is, right below this is kind of a checklist that you can go through to see, can I use my shortcut on this trinomial or not? So the very first thing we want to check, and we're actually going to kind of test it out with this first example here, are the first and last term perfect squares? So I need to look at the first term and the last term. So in this case, those are perfect squares because 9y squared is 3y times 3y. So I can square root that. I can also square root 16 because 16 breaks down into 4 times 4. So in this case, yes, they're perfect squares. So now I have to check and see if the middle term is following the correct pattern. So is it following that 2 times a times b pattern? So to get that, see if it's following the pattern, I want to take the square roots of the first and the last term. So that would be 3y and 4. And I'm going to multiply them together. So that gives me 12y. So multiply the square roots of the first and last term, and then I'm going to double that. 24y. Whoops, I forgot my 4. 24y. So is your answer the same as the middle term? So in this case, yes, it is exactly the same as the middle term. So that means I can use my shortcut. So my shortcut for this would be to just grab the a and the b. So that's the square root of the first term and the square root of the last term, the 3y and the 4. And those are the parts of my factored expression. So it's just going to be 3y plus 4 squared. Or if you wanted to expand that out, 3y plus 4 times 3y plus 4. But it's shorter just to write 3y plus 4 squared. So always check and see if your trinomial follows that pattern, if you can use that shortcut. So here's another example. So we can practice just kind of following these steps. So the very first thing we want to check and see is, are the first term and the last term perfect squares? So in this problem, this is a perfect square. This is 5 times 5. But this, not a perfect square. So the x squared I could break down into x times x, but the 2 is not a perfect square, so I can't break that down. So that's not a perfect square, so that means I cannot use the shortcut on this problem. I would have to use the regular steps. So our regular steps, since this has a leading coefficient of 2, we would have to go through our process for a problem that has a leading coefficient. So I would multiply the 2 times 25, which is 50. So that means I'm looking for a pair of numbers that multiply to 50 and add to 10, because that's the middle term. So if I go through this, the different things that multiply to 50 are 1 and 50. That's not going to add to 10. 2 and 25. That's also not going to add to 10. 5 and 10. That's also not going to add to 10. So those are the different ways that you can break apart 50, and none of them add to 10, which means that this one actually is prime, because there's no combination that's going to work. It's not following our shortcut, so it's not a perfect square trinomial, and our regular steps, we're not getting a combination that works, so that means it's prime. So at this point, we've got several different factoring strategies. We have factoring out the greatest common factor, so factoring that way. We have what we're going to call our regular trinomial strategy. So that's where you're looking for a pair of numbers that add to a certain amount and then multiply to a certain amount. And then we've got a couple of shortcuts that we can keep an eye out for. So we can keep an eye out for the difference of squares shortcut from yesterday. And we can also keep an eye out for this perfect square trinomial shortcut. So if it's following this pattern, then we can shortcut straight to the factored form without doing any extra work. At this point, any of those different types of problems are fair game. And your assignment today is actually going to be a mix of the different types of factoring we've been doing. So we've talked about all the different types of factoring, but when all is said and done, you have to be able to recognize what type you need to use and decide on the correct strategy to factor any problem that is thrown at you. So factoring summary, this is basically kind of your checklist to factor any polynomial based off of the things we've been learning so far in this chapter. So the very first thing, and this has been mentioned a couple of times in previous lessons, so the very first thing is always factor out the greatest common factor if possible. So if there's a GCF you can pull out, pull it out, because it makes the rest of the problem have smaller numbers, and smaller numbers are always easier. So always factor out a GCF if possible. After you factor out your GCF, if you can, the very next thing you want to do is check for shortcuts. So check and see, is it a difference of squares? So that was our shortcut from yesterday. So is it following that pattern? Or is it a perfect square trinomial, which is the pattern we were just reviewing a minute ago? So if it's either of those and you recognize the pattern, then you can shortcut from the answer straight to the factored form just by following the pattern without doing a bunch of extra work, and then you're done. So if you can use a shortcut, use a shortcut. So if it's not a different squares or a perfect square trinomial, then we have to apply our, we're going to call it our regular trinomial strategy. Regular, spell it carefully. So that's the one where we're adding to a certain amount and then multiplying to a certain amount. So that strategy. So it's a strategy that we tried on this guy before we figured out it was prime. So use our regular strategy for trinomials, or if it's bigger than a trinomial, so if you have like 4 terms, then you can also try our factor by grouping. So that is knowing that we've got several different strategies for factoring at this point in the chapter. That is your checklist of the order that you should tackle any factoring problem. So check for the greatest common factor first. Check for the shortcut pattern second. And then when you've done both of those things, if it's not a difference of squares or a perfect square trinomial, then you're going to resort to our kind of regular find a pair of numbers that adds to this and multiplies to this strategy, or our factoring by grouping strategy if it's not a trinomial that we've been using in this chapter. So like I said, today your assignment is going to be some more factoring practice. It's going to have a mix of the different types of factoring that we've been doing so that you can review the different types, and also so you can think about identifying the correct strategy, because that's an important skill since we do have like 4 different strategies at this point that we can use to factor with. And then mixed in with that is going to be this perfect square trinomial pattern. So now you have to keep an eye out for that pattern as well. So when you are ready, your notes are all filled out, then you can move on and go ahead and try today's assignment.